Welcome back, Hononegah Geometry. Today we're going to do 1.6, but before we start doing that, let's do a little bit of review. Find the value of x. Notice it makes a straight line. We talked about straight angles previously. Straight angles always add up to 180 degrees. So taking both of those angles, adding them together, adding like terms, remember algebra now. And so dividing by 5, x is equal to 34. Next, find the value of x if BC bisects. This goes back to our previous section, section 1.5. The word bisects means cut in half, or cut into two equal or congruent angles. And so setting that up, 3x plus 11 equals 5x minus 1. Sorry about that. Typo there. 2x equals 12. I got x equals 6. And it asked me to find the value of x. All right, today we're going to talk about describing different pairs of angles. And so the first pair of angles we're going to talk about is adjacent angles. Adjacent angles share a side and share a vertex. Both of those. They have to share a side and share a vertex. So that's an and situation. Okay, have a common vertex and a common side. So these two angles, 5 and 6 in the first picture right here, are adjacent angles because they share a side and they share the vertex. So the next two are non-adjacent sides. Notice they do not share a side and they do not share a vertex. So neither one of those items are shared with angle 7 and angle 8. And the next one we're going to talk about is complementary. So complementary and supplementary, and this is a big one. This is huge. We're going to talk lots about complementary and supplementary, lots of questions on quizzes and tests about complementary and supplementary. Two angles whose sum is 90 degrees. That is complementary. Every time I say complementary, you should automatically think 90 degrees. Two angles, and notice I said two angles, not 3 and 4 and 5 angles that add up to 90 degrees, two angles that add up to 90 degrees. You'll notice in this picture there's a symbol. That symbol is always a right angle symbol. So when I see this little square in the corner, I automatically think 90 degrees. So now the next one, supplementary. Supplementary is the sum of two angles that add up to 180. So notice this one right here is supplementary because it makes a straight angle. We already know that straight angles are 180 degrees. So 115 plus 65 adds up to 180. Those angles are supplementary. With that being said, now in the diagram, name a pair of adjacent angles, a pair of complementary angles, and a pair of supplementary angles. So now, adjacent. Adjacent merely means shares a side and shares a vertex. So angle BAC, and I'll use some color here, BAC, is adjacent to CAD. Let me write that a little better. So BAC and CAD are adjacent. Again, adjacent means shares a side, shares an angle. Now, complementary. Complementary means it has to add up to 90. So 57, again, using a little color here, 37, and 53 add up to 90 degrees. What that means is angle, I'm going to put it up here, BAC, and angle RST are complementary. I'm just going to abbreviate COMP. Next one, I want two angles that are supplementary. Supplementary means adds up to 180. So 127 and 53 add up to 180. So angle CAD and angle RST are supplementary. And again, I abbreviated there. So the next question, angle 1 is complementary to angle 2, and angle 1 is 62 degrees. Find angle 2. Complementary means 90 degrees. So if angle 1 is 62, then angle 2 has to be 28 because it has to add up to 90 degrees. Angle 3 and angle 4 are supplementary. Remember, supplementary is 180 degrees. If angle 4 is 47, I take 180 minus 47, I get 133. Now, doing this more as an equation, angle LMN and angle PQR are complementary angles. Find the measure of angle LMN if 4x minus 2 and 9x plus 1 have to add up to 90 degrees because they're complementary. Now, I don't have a lot of space on this particular one, so I'm going to scroll down, but algebra, 13x equals 91. Divide by 13, x would equal 7. And it just says find the measure of the angles. It's a common mistake here is to stop. Yes, x does equal 7, but angle, the measure of angle LMN, when I plug 7 in here, is 26. And the measure of angle PQR, plugging that in, is 64 degrees. Next one, modeling real life now. We have a soccer goal with an angle. When viewed from the side, the frames of the ball return net forms a pair of supplementary angles with the ground. Find BCE and ECD. These two angles make a straight line and are supplementary. So the two angles add up to 180 degrees. Back to algebra. 8x equals, I'm going to subtract, I'm going to get 168 divided by 8, x equals 21. Now remember, they don't want x, they want the angle. So angle ECD, when I plug 21 in, is 65, and angle BCE, when I plug 21 in, is 115 degrees. Next one. Linear pairs and vertical angles. Linear paired, this is another way of talking about straight lines. Two angles that are supplementary and adjacent. Okay, two adjacent angles are a linear pair when the non-common sides are opposite rays. When I see a straight line and there are two angles, they are also known as a linear pair. All linear pairs are supplementary. So it's kind of just another way of saying supplementary angles, but linear pair making a straight line. So there has to be both adjacent and supplementary to be called a linear pair. The next one, vertical angles. Put a big star by this one. This is used a lot. We will have lots of proofs later on in the semester in which vertical angles. Vertical angles are opposite angles of two straight lines. So I have two straight lines here, angle 3 and angle 6. I like to refer to them as the opposite sides of an X. So 3 and 6 are vertical angles, and so are 4 and 5. So 4 and 5, I should have used a little different color there, are vertical angles. Now, identify the angles in the picture. So I want all linear pairs. So angle 1 and, I'm going to write a little and symbol, angle 4 are a linear pair. I'm just going to abbreviate LP. Angle 4 and angle 5 are a linear pair. So two angles that make a straight line are linear pairs. Now vertical angles, you got to be real careful. 2 and 4 are not vertical angles, but angle 1 and angle 5 are vertical. It has to be the opposite sides of a complete X. So I'm going to use here's one straight line, here's one straight line, which makes 1 and 5 vertical angles. Notice that 4 is not a vertical angle with 2 and 3, or 2 or 3. Two angles form a linear pair. Measure Now, linear pair is literally saying the same thing as supplementary. The measure of one angle is 5 times the measure of the other. So if one angle is x, the other angle is 5x. And remember, linear pair. Algebra, x would have to equal 30, which then makes the other angle, so one angle is 30, and the measure of the second angle is 150. Try these, and obviously you don't have a neighbor, but try these. The measure of an angle is twice the measure of its complement. Find the measure of each angle. So, and I think the answer is under the box, but I'm not able to move it. So here we go. The measure of an angle, so we'll call that one x, is twice the measure of its complement. So twice the measure, and its complement are 90. So now, adding those together, I get 3x equals 90, x is equal to 30, which means one angle is 30, and the other angle, we'll call them angle 1 and angle 2. So angle 1 is 30, angle 2 is 60. The other one's way more complicated. Two angles form a linear pair. Again, linear pair. The measure of one angle is 1.5 times the measure of the other. So one angle and the other one adds up to 180. Now, those of you that don't like fractions, this isn't a good question for you. Use that as 1.5. That might be a little easier. So instead of 1.5, I would go 1 plus 1.5 makes 2.5, or 2.5, equals 180. Now, using a calculator, I'm going to take 180, I'm going to divide that by 2.5, and I'm going to get 72. So if one angle is 72, the other angle is 108. Remember, angle 1 then and angle 2. Last topic. Anytime we start looking at pictures, interpreting diagrams, there are some things you can conclude from a diagram. If I look at a diagram, there are certain things that I can say, even though it's not marked, it's true. All the points are coplanar. Fine, they're all in the same plane. A, B, and C are collinear. If it looks like it makes a straight line, we can assume that it does. We can assume then also in the picture, there's line AC, there's ray BD, and then BE intersect at B. So if it looks like they cross at that point, they do cross at that point. Or touch at that point, they do. DBE and EBC are adjacent angles, and then ABC is a straight angle, and that point E lies on the interior of angle DBC. These are the things that I can assume just looking at pictures. You don't need to be told them. However, these are the things that you cannot assume. You can't say, well, it looks like AB is congruent to BC. Can't conclude that. Can't say that for sure. It looks like DBE is congruent to EBC. Can't say that. Don't know that for sure. It looks like ABD might be a right angle. Can't conclude that. So you cannot assume anything's congruent or equal, and you can't assume a right angle. Now, if I give you marks in a picture, though, you can. Notice that this mark and this mark means that those two are congruent. If I give you one line and one line for angles, you can assume those are congruent. And if we get a box in a picture, you can assume that is 90 degrees then. So if they give you information, then you can conclude it. Now, check here with your teacher in the Google Classroom, and have good luck.